that I can open in CAD Nano. So for instance, I can go here. Okay, and say, open the last example. It will generate this. And this structure, I'm going to do that. And I can create a variety of options in using software programming source, for instance, 4K in range, and I can say 2. And I can just create 2 of them in a row, or maybe I can create 8. I don't know. This is just a matter of how do you want to describe your structure. And you can say, for instance, red up, and I can copy it back here, red down. So this software, the purpose of this software is to bring flexibility, parameterizable things to what we are describing, because if you come here to CAD Nano, I don't know if you have used it before, but if you come here to CAD Nano and draw it again, you have to do a fix. Oh, okay, for instance, the width of this is not what I want, so I just can modify this, say 80, is going to be a little bit sharper, wider. Also, there is some extra commands I can say. I can control this corner. There should be 20. I want to go back before the corner, so it is going to be an interesting way to define it. I just can come here, open the sample I'm going to have my structure. And I can go, so this is Blender. This is the Blender interface. It's a 3D software, a standard 3D software. I didn't do Blender. I just created Mendel. But as Python, it can be opened and run here, and it will just run normally until the right Nano, and the render is some commands that are exclusively for Mendel, for Blender, sorry. And as this is a Blender, I can have, for instance, other subfiles I can try, I can test. And this is a little bit more complex that is actually in the picture. That I said, I want to generate the FNANO word. So it takes a little bit long, but it will generate the FNANO word. And this has 3 layers. Actually, it's 2 layers, one and 2 layers, and it has a frame to give it stability. Okay, I can move this. When we are defining this, we can have a number of base pairs you're using, how many scaffolds are required. Okay, in this case, I just using one scaffold, but we can add more. And as you can see, we can have this. This is the frame, and we have the other structure. And basically, that is it. I just can come and open the FNANO in 2 layers I have chosen. And it will just open. As there was a big structure, it takes time in CAD Nano to open. So doing this by hand, I think is a little bit more difficult. All right. So we can. There are some limitations that because this software is all right in the early stages. So by now it is only using this. How can I say, Cartesian coordinates, and it can grow in x, in y and z coordinates. Let me go back to the initial example. And in this case, okay, it needs to. So for instance, I was doing this. There is a planar in x and y. If I want to go to z, I can use this command, grow, and I can say, okay, grow in the C++. So if I run this command, instead of this the last stage, doing that is going to grow in the C direction. So this is back down. I can do rect up. So it can go up in the Z direction. And if I wanted to go in the opposite direction, I can say Z minus. And this is going to be so tricky because we are going to see that they are going to match in this position. So I want to go do them, but all them are going to do that. So I just need to do an extra here. And I will put just one in pair, so to reduce. This is just a tricks I have to learn. I have learned about that, and I can do my other structure in the other direction. And so on, so we can construct many structures. So let me copy this back. And I can say, for instance, y plus again. So I'm going to have the other returning and red down, or red up. Or then a red up. Yeah. So, okay. Oh, it should be red down. But you can see what we are doing. We can just step by step define one structure, say, okay, how it's going to be done. And just doing this takes time by hand, but using this commenting is okay. We just have to come back here to FNANO. And as this software is not perfect, we can notice some parts in which, okay, this scaffold, this staples were a little bit, okay, I want to fix this because it's too short here. But okay, that few design details we can fix by hand. But basically, it helps a lot in the designing process of the origami structure when we really need to do parameterizing one. And also, you can say these are numbers. We can generate them in different way. Just to have, instead of numbers, we can have variables. So we can say thickness equals 80, and I can just modify this t. And all right, I just run this code once. It will show me all of them running as 80 in the thickness, but I can just modify this 20, and it's going to show me a different result. All right, so there are some, as this was having, you can see, and returning out 20, so it's going to cancel itself. But basically that is it, what is the software can do. Pretty easy for many things, pretty tricky for other when we really need to have control and advanced control. Okay, you need to understand how is the process of doing this. For instance, as I wanted to do this to go back, I needed to add a rectangle with an impair with an odd number. So when you are having the return, it's going to point in the opposite direction. So all of them are going to start in the opposite corner. If you are starting in the same corner and growing in one direction, they're going to just stack. So if I just put this, and they stack together here, because they didn't change the last direction of the position. But okay, this is part of the trick, is we can just know and how we can create this structure. You have questions?
I have a question. So are they just only rectangular structures that you create?
By now, yes.
Okay.
This is By now, it is just rectangular approaches. Right now, the next step. Okay, the main concern that we're having by now is the proper generation of the staples, trying to get staples that gives structural stability. So it tries to generate as primarily the opposite staples, and then it's going to compute the others to have structural stability. But the future works, as you have already said. There are support of honeycomb structure, honeycomb lattice, sorry, and support of curves. So yes, in the future we can have diagonal points of view, diagonal structures. But this concept is just it uses not fixed location as Cat Nano does. It computes the things according to the Cartesian coordinates. So any interaction, if I have a diagonal structure here, it will detect if they are close enough and they are if they are aligned in the proper way to have the staple. So in the matter of time, it could have very good work for this kind of structures that are not exactly rectangular.
And then my other question is, because I can see that you can export it to a JSON file for CAD Nano.
That's true.
Can you import a CAD Nano JSON file to this framework?
No, it cannot do that by now. This could be something that can be done, but it's not in my near plans. But as the team in which I'm working on is growing, maybe one of my lab mates could be interested in building that importing feature. I think probably it's not so difficult, and probably I will take it. It is not so difficult, and it could be interesting to add it. Yeah, it's actually a very nice question. Thank you.
Yeah, no problem. It's a really interesting framework that you have.
Thanks. Hello. Did you see the previous presentation, or you just have arrived? Oh, I can hear you. No, I can't hear you. Oh, you can write me. Is there a documentation? Oh, yes, there is documentation. Oh, okay, she was doing that. Yes, there is a documentation. We have the Mendel. It is available in that location. Sorry, I can hear you. You can text. I try. Okay.
Hello, Jorge. Seth.
Hello. How are you?
Hello. Good. How are you?
Very
Where
good.
are
Very
you?
good.
Where are you, Jorge?
I am fine, and I'm from Colombia. All right.
Where are you now?
Oh, I am in Greensboro, North Carolina.
Okay.
Okay.
Can you go through your presentation?
Of course, I will. Okay, share my screen again. Okay, can you see my screen?
Yes, I do. Thank you.
Okay, perfect. All right. So I was doing an example in my previous presentation, but basically, what is Mendel, the software I have developed, is a software that allows me to create structures, describing them by using simple commands. So let me erase this, so starting again. So we can start showing this part examples. I want to create a thin origami structure, but normally, if you are familiar with thin origami,
I am.
You are?
I'm familiar with CAD Nano, yes.
CAD Nano, perfect. So normally, when we are working with CAD Nano, we just go and do this manually, right?
Yeah, yes.
But when we are reaching a problem, okay, we want to have this bigger, and I have to do that again in CAD Nano. I just modify the parameter, and I will just come here, open the document, and I just have my structure defined with my software. And as you can see, so the commands are pretty straightforward. So this is a rectangle with a thickness. So the thickness, I put a value. I can put directly the number here, 40, or I can put the T just instead of that. I can define the number of turns I want to have, 1, 2, 3, 4. So I can have 8 turns. It's going to have more. Basically, this is the most common command I use, and I just combine that to generate more and more structures.
Okay. So T is what? What does T mean?
Oh,
T
okay.
is
T is a parameter. I created a Python variable, but I can put directly 80, right?
Okay, but the first parameter is what? Is the number of what? Basis?
Okay,
the number of
this first parameter is the nucleotides I want to add before the default
turn.
Yeah, default turn.
Okay.
And you can pay 80, so it has 80, and then it's going to compute default, and then other 80 and compute default, and so on.
Okay, so two means that you're going to have 3 helices.
Yes, but it has 2 turns. One turn, 2 turns. That's
Got it. And so this is 2D. So now if I want to go in the orthogonal direction.
Yeah. So, okay, I did another parameter here just to show I can add, I can add, for instance, 8, and it's going to add 8 times these things. Just because I defined.
But I could add it different ways.
Yeah, yes. So if I define this, I can create it as. If you want to go, so you told me you want to go in the opposite in the Z direction, right? So I just add the parameter to growth in the Z direction, and I say this is going to be this. So 4, 4.
Okay, but what if I want to route? What happens if I want to route something like this? You know, I want to make this structure.
Oh, sorry. Are you texting something?
No, I'm saying.
The curve. Okay,
yeah,
the curve.
I want to route this cup, you know?
Oh, all right, yeah.
It's
okay, as the software is in the early stages, right? I really want to do that. It is limited now to rectangular coordinates. It doesn't. So we can so in somehow create the cup, but very square, right? As you can see, we can create it very square. It is limited by that by now, but that's part of the future work. On once we have settled down all the current features and bug fixed all of them and have experimental results to demonstrate that all this is working.
This is good for making blocks. What do you envision as your kind of range of shapes that you could make?
All right. As you know, the main idea of this software is to provide parameterizable structures. So, and at the end, it's going to be a help, right? And this is one example I was just running before. And the complexity of them are going to increase once we have the ability to create curves and to create, yes, so we can create curves, so we can put diagonal planes, whatever. But as they are parameterized, so we can create more complex structures. So you can see this is done just by commands in Cartesians.
Is that the code here?
What do you say?
Is this the code? Is the code for this on the right there on the screen? This is the code?
Yes. So you can see the F, the code for the F, one space, the code for the N. So the code for the N, it has the rectangle that goes up, and for loop that creates a diagonal. And there's going to be up and down, and so on. So the A is going to be these other comments. It is really and somehow it's very straightforward. So let me show how we can create.
How's the routing? What's the routing in this?
Sorry, what?
What does the routing look like? The routing of the scaffold. What does the routing look like in this?
Okay. Let me show
the routing it must be non-trivial.
Yeah. Okay. That's a very nice question.
I mean, because if I edit it, then how does it recompute the routing?
Yeah. So in this case, this is the structure it was created. It has I define a frame that will give a stability, because otherwise they are going to be very lost, the other parts. So I added this frame, but this goes here. You can see that the scaffold, it goes up here. It just goes here to create the frame and returns here in this part. And here we can start the F and the A, and when it finish, it will return back, and it will generate the next layer.
But if I edit it, let's say I say, oh, I misspelled, and now I want to cut out one letter and put another letter back. Then what happens?
Okay, that's a very nice question. Let me show you, actually. Let me reduce the amount of layers, because range layers, I will put 1. So, yes, you are right. Let's do this example. I have the A and O, right? I can just add another N. As this is a big structure, it will take a little bit more for my computer to do that. But so I have N. I can omit this N, and I will just add it. So it's going to be F-A-N-O.
Yeah.
Okay, F-A-N-O. So I just can remove that, and I can, as I know this is for defining the N, I can put that before the, after the A, so we can have it between them. So I can have 2 times the N.
Okay. Yeah.
Yeah. I can copy the space here. And the only bad part is this is Python. So Python requires your code to be properly defined. Sometimes we can have, so anytime we are doing some modification, okay, you can see that, right? So we have double N.
Yeah.
So if we define the structures, and okay, this is part of software coding, but I know that N is between this and this. I just can copy the code and use it and repeat the structure. And so as you have said, the spelling, I just can have this segment of code. I know this is going to work, and we'll add it.
Okay. Okay, very nice.
Thank you.
Yeah, I'll be interested in trying it. And, the routing is really important for the yield, when you're going to make the object, and so it's not just it's not just that the routing be continuous. That's not enough to make a good structure.
All right.
In complicated structures, structures that have holes and everything, it's the actual way that you fold it. The way the origami is going to fold depends on the routing, and so there's there needs to be some physics also input in order to have there's an infinite number of ways you can route.
That's true.
But some fold better than others.
Definitely.
And so one needs to, that's the advantage of CAD Nano, is that you, as the scientist, set the routing, which is kind of, important in some cases, very important how well the structure will fold. So it depends. I mean, there's some simple things the routing doesn't matter, but then there's more complex things where the routing is quite important. And so being able to edit that routing is an important feature.
That's true. That the software just tries to abstract the part. I appreciate the point, and I should be taking into account. I don't know exactly what or how to do that. But at the end, we can export it to CAD Nano and have the manual input.
Yeah, but at that point you can't. Once in CAD Nano, once it's routed, you can't unroute it. That doesn't work. So anyway, there should be some way at the beginning, kind of, in some sense, give it some guidance on how to route, or by the sequence at which you build up, the blocks to bigger and bigger structure. There should be, maybe you can enforce the routing that way, like make a subunit and then combine the subunits.
All right, that part that can be included in the way that Mendel works. So the current developments have been focused on how to make the structurally stability as our current knowledge, right? So in this case, we need a little bit more expert point of view and have a understanding of how to parameterize them.
Yeah. I'll put you in contact with some people in my group. We're making very complex three-dimensional structures, but they're very symmetric structures. And then we're making all kinds of modifications. It would be interesting. I mean, we can share with you some of our kind of our concepts or our routing things. And I'm wondering if that's something that can be incorporated. There's, maybe we can have some discussion, after the meeting.
All right, that could be nice.
But yeah, it looks like a nice tool, and be interesting to explore that further.
Oh, perfect. Thank you.
Right,
I will send you my contact.
Yeah, I guess it's in the FNANO thing, right? Or.
Oh yeah. Okay.
I mean, send it to me. Sure. I mean, I can. Right. I suppose I can find you, North Carolina, A&T State University. I guess I can find you, Jorge. But anyway, no, send it to me. That's great.
Okay, thank you. I will.
Thank you. See you later. Bye.
See you later. Bye bye.